we have seen that Narayan, a money lender, lent money to his friends at the rate of 20%. So let's say that he is lending a sum of money, rupees 1 lakh, to his friend Sundar for 1 year. So at the end of 1 year, the total amount of money that he is getting back is 1,20,000. Now Narayan had also seen that if he charges interest on interest for multiple years, or in other words, if he charges compound interest for a given number of years, then he stands to gain more. Now Narayan was a very shrewd businessman. He wondered that what if instead of every individual year, I charge interest on interest within a year? So Narayan thought that let's take a period of 6 months and I will compound the interest after every 6 months. So in this case, if the rate of interest in 1 year is 20%, then the rate of interest for 6 months would be half of that. In this case, 10%. And Narayan wondered what would happen if I compound this interest after every half year or after every 6 months. Let us find out. So let's consider the first 6 months. Let's say that at the end of first 6 months, the amount that he's supposed to be getting back is A1. So A1 will be nothing but P whole into 1 plus R by 100. So I will replace the values of P with 1 lakh and R with 10. Because we are considering only for the first 6 months. So R will be half. So 1 lakh into 1 plus 10 by 100. Now on further simplification of this, I will get amount A1 as 1 lakh 10,000. So 1 lakh 10,000 is the amount at the end of the first 6 months. So this amount A1 will be equal to the principal for the next 6 months. Let's call it P2. So this is equal to the principal P2 for the next 6 months. That is 1,10,000. So the amount at the end of the next 6 months, that is at the end of the year, will be A2 will equal to P2 multiplied by 1 plus R by 100. So again I replace the values. P2 is nothing but 1,10,000. So 1,10,000 into 1 plus R by 100. Over here R is equal to 10 because as I mentioned to you before, we are considering 6-month period. So if I simplify this equation, I will get a value of 1,21,000. So 1,21,000 is the amount of money that he will be getting back after the next 6 months, or in effect after the end of the complete year. So now let us compare the two scenarios. We found initially that when the rate of interest was being charged per annum or per year, Narayan got back 1,20,000 as the amount. But if Narayan charged compound interest or interest on interest within a year, he got back 1,21,000. So as we can see, he is getting rupees 1,000 more in the latter case than in the previous one. So this is because the amount of money is being compounded 2 times in 1 year. Over here there was no compounding taking place because we had considered only a single year. However, if inside a single year we carry out compounding, as in this case twice, we find that there is an increase in the amount of money that is got back by Narayan. So we can generalize this scenario for any sum of money. Over here we have annual compounding as well as semi-annual or half-yearly compounding. That is compounding at the end of 6 months. So let's say that the principal is P, the rate of interest per annum is R, and it is being invested or lent out for T years. So when interest is compounded to the principal at the end of every year, we consider R as what has been given to us. However, if the same interest is being compounded half yearly or semi-annually, then we have to consider the half of the rate of interest given to us, that is R by 2. because when it is being compounded annually, for t years, it is being compounded t times. However, if it is being compounded twice in 1 year, then for t years, it will be compounded 2 into t times. So what can we write the formula as? We can write that the amount will be p into 1 plus r by 100 to the power of t. Whereas in this case, we can write the amount will be p into 1 plus r by 2 by 100 into 2t. Thus, this will be the formula if it is compounded t times, and this will be the formula if it is compounded 2t times. So the first one is for annual compounding, the second one is for half yearly compounding. Now we can derive a similar formula if it is being compounded quarterly. What happens in that case? When the amount of money is being compounded quarterly, it means interest is being charged or given 4 times in a single year. So that means we have to consider 4 divisions of a year or a quarter. So in that case, if interest is compounded to the principal at the end of every quarter, then we need to consider r divided by 4. So r is the rate that has been given to us divided by 4 because it is being considered for every quarter. And as we can see, if the amount of money is compounded 4 times in 1 year, then it will be compounded 4t times in t years, and the formula will be A equals P into 1 plus R by 4 by 100 to the power of 4t. So this will give us the amount if the amount of money, that is the principal, is compounded quarterly. So now let us do a simple sum in order to strengthen our concept. The sum states that we are depositing rupees 10,000 in the bank, and the bank is compounding this amount of money quarterly at an interest rate of 8% per annum. So how much money will we have at the year's end? Now notice over here the interest rate has been given as per annum. However, it has also been given to us that the bank is compounding the money quarterly, or in other words 4 times in 1 year. So the formula which we will apply is A equals P into 1 plus R by 4 by 100 to the power of 4 into T. Now over here all I need to do is replace the values of what has been given to us. P has been given as 10,000. R has been given as 8. So 8 by 4 will be equal to 2. So I write 2 by 100. And it has also been given that only a period of 1 year is being considered. So t is equal to 1. So 4t is equal to 4. So we find that this is the amount that I will receive if I invest 10,000 in the bank for a period of 1 year, given that the bank is compounding the interest quarterly. So if I simplify this equation further, I will get 10,000 into 102 by 100 to the power of 4. So this equation can be further simplified in order to obtain the amount that I will be receiving at the end of 1 year, given that quarterly compounding is taking place. So on further simplification of the equation, I find that the amount I'm receiving at the end of 1 year, given that quarterly compounding is taking place, is 10,824. So initially I invest rupees 10,000, and at the end of 1 year, I get back rupees 10,824 because the amount had been compounded quarterly. Now instead of quarterly compounding, what if the compounding would have been annual? In that case, the formula to be applied would have been P 1 plus R by 100 to the power of T. Now over here T is 1, P remains 10,000, and R is equal to 8%. So I would have gotten 10,000 into 108 divided by 100. So cancelling two zeros, I find that the amount I would have received would have been 10,800. So as you can clearly see, when the amount is quarterly compounded, that is the amount of money I invest in the beginning, the amount I receive at the end of the period is more for quarterly compounding than in case of annual compounding.